Okay, the last way we're going to represent solution sets is with what's called interval notation. So we have, so far we're using inequalities, we're using graphs, and then we're going to use interval notation. So what interval notation is interval notation is kind of like a shorthand inequality. It's a quicker way to write an inequality. But what it does is it states the set of all solutions between two endpoints. States the set of all solutions between two endpoints. And for right now, we'll call our two endpoints A and B. Okay. All right, so the format for interval notation is you're just going to have your two endpoints, A and B, and you just separate them with a comma. So you got endpoint A, endpoint B. Now endpoint A has to be the smaller value. So endpoint A has to be the smaller number. Okay, so you're going to have two endpoints. Obviously one's going to be bigger than the other. A needs to be the smaller one, which means B has to be the larger number. So same thing as with the number line. Your number lines have to be in order from smallest to biggest. Same with your intervals. Your intervals have to be in order from the smaller value to the bigger value. Okay. And just like on a number line, if you flip the order around, you'll miss half point or something. Okay, so that format looks kind of familiar. We've seen a number, comma, another number. So it is what most people think. It looks like an ordered pair, and it does. It's written like an ordered pair, but it actually represents a continuous interval. It is written like an ordered pair. Ordered pairs are x comma y. These are endpoint comma endpoints. It's written like an ordered pair, but it represents all numbers in between those two endpoints. So it represents the continuous interval So written like an ordered pair, but represents a continuous interval between whatever those two endpoints are. So how do you know if it's an ordered pair or how do you know if it's an interval? It just depends on the context of whatever you're doing with math. If you're plotting points, it's probably an ordered pair. But if you're describing a solution set to an inequality, it's going to be an interval. Okay. To make matters worse, for the ordered pair as an interval is an ordered pair, to make matters worse, your interval is going to be surrounded by two things. Okay, and there's two options for these. So your smaller value is going to get one of these two pieces, and your larger value is going to get one of these two pieces. So your interval is going to be surrounded by either by a set of parentheses, so just normal parentheses, or square brackets. Okay. So endpoint A is either going to have a parenthesis around it or a square bracket. Endpoint B is either going to have a parenthesis around it or a square bracket. It has to be one of those two, but they don't have to match. So A and B can have different. So one could have a parenthesis, one could have a bracket. They don't have to match. Okay. All right, so what's the difference between a parenthesis and a bracket? The parenthesis means not included. Okay. So it means that value, that endpoint, is not part of the solution set. Well, what else means not included that we're already familiar with? Well, with inequalities, if we mean something's not included, we use the open circle. Well, when do we use the open circle? Well, for an inequality, we use the open circle whenever there's a greater than or a less than. So in any of those scenarios, that means you're going to use a parenthesis. Okay, if the number is not included, if there's an open circle, if there's less than or greater than. Okay, the opposite is true for the brackets. The bracket means that endpoint is included. Okay, or if there's a closed circle, okay, or if there's a greater than or equal to or less than or equal to. Okay. So the or equal to's, the closed circles, the included values get a square bracket. Again, what that would mean is that means that number, that endpoint is included in the solution set. If it has a parenthesis, it means that endpoint is not included in the solution set. Okay, so let's look at some examples. This first example, 2 is less than or equal to x, which is less than 13. Okay, so compound, compact, and inequality. We're going to do it in all three versions. So we have the inequality, we're going to make it a graph, and we're going to make it an interval. First up is the graph. Okay, we know how to graph this. We were graphing inequalities earlier. So we know we're going to need our 2 on the number line. We're going to need our 13 on the number line. And again, I'm going to make these just rough number lines. You know, it doesn't have to be even for this, for the notes. All right. And then remember, for graphing inequalities, we need to determine the type of circle, and we need to determine the direction of shading. Okay. So the 2 is less than or equal to. So that's going to have a closed circle at 2. The 13 is just less than, so that's going to have an open circle, and x is between those values, so we're going to shade between those values. So you could shade or use your arrows. Okay, so that's the graphical solution set. What's the interval for this? Okay, well, you need your 2 endpoints. Our endpoints are 2 and 13. Okay, so we're going to have 2, comma 13. Okay. And then, again, you could look at the inequality part, you could look at the graph. 2 is an or equal to, it has a closed circle, so that means the 2 is going to get a bracket. Okay, a square bracket. The 13 is not included. 13 has an open circle. It has a less than sign. So the 13 is going to get a parenthesis. So bracket 2, comma 13 parenthesis. What that means, it means all values between 2 and 13, 2 is included, 13 is not. Okay. So it's just a shorthand. It's, you know, it's faster than making a graph. It's faster than writing an inequality. So get another one. 1 is less than x, which is less than 4. So another compact inequality. If we were graphing this on our number line, we would need a 1. We would need a 4. I'll just space it out. Okay. They would both have an open circle because there's no or equal to's. So that means 1 is not included and 4 is not included. You would shade in between. Okay. And that's the graph. But what's our interval? Okay. So the interval, again, you need the endpoints. 1, comma 4. Okay. And then you need to pick bracket or parenthesis. Bracket if it's included, parenthesis if it's not included. Neither the 1 nor the 4 is included, so both would have a parenthesis. Okay. Now again, especially in this form, that looks like an ordered pair. It looks like the 0.14. It's not an ordered pair because it's in the context of a problem, in the context of a solution set inequality, we know it's going to represent an interval. Okay. All right, so those were compound and inequalities. What if you just have a simple open-ended inequality? X is less than 10. Less than or equal to 10. Okay, on a graph, we know what this is going to look like. We know it's going to be a closed circle at 10. And it's going to be shaded to the left, less than to the left. So closed circle at 10. And again, just for these notes, I'm not putting the full number line. I'm just putting the number in the middle. Shaded to the left. Okay, well, how are we going to represent that with an interval? Because there's no smallest endpoint. We have one number. We just have 10. Is that, 10 is the biggest number, but what's the smallest number? So off to the side here, I'll put the note. Interval notation. If there's not an endpoint, okay, or if it's a simple inequality, meaning your graph is just going to keep going on forever, okay, there's an infinite number of numbers that are less than infinite or less than 10. Okay. So we use something that's not a number. Okay. Interval notation is going to use positive and negative infinity. So if you don't have a smallest number, or you don't have a smallest endpoint, it's going to be negative infinity. If you don't have the biggest number, so if it's shaded to the right forever, you're going to have a positive infinity as your endpoint. Okay. So the infinity sign, that's positive infinity. If there's a negative in front, it's negative infinity. All right, and infinity always uses a parenthesis. Okay. So infinity is not actually a number, so you can't ever actually get there. So infinity is never going to be included. So it's always a parenthesis. All right, so back to this. X is less than or equal to 10. Okay. There's no smallest value. It's shaded to the left. It's going to keep on going to the left forever. So we're going to use negative infinity as our smallest value, as our smaller endpoint. It's going all the way up to 10. So those are our two endpoints, negative infinity and 10. What's going to go around them? Like I said, infinity always gets a parenthesis. Always open parenthesis. And 10, since it has a closed circle, since it's less than or equal to, 10 gets a bracket. Okay. So parenthesis, negative infinity to 10. 10 gets a bracket, 10 is included. Okay. This next one, you're given the graph. Okay. You're given the graph, but not the inequality. So again, we're going to have to be able to go between all three of these forms, graphs, inequalities, and intervals. All right, so we have a graph, we don't have an inequality, so let's write the inequality. On this graph, we have an open circle at 3, and it's shaded to the right. Okay, to the right of 3 are numbers that are bigger than 3. So our inequality is going to be x is greater than 3. Okay. Greater than, because it's shaded to the right. Greater than, not or equal to, because it's an open circle. All right, so what's that interval? Well, we have a smallest value, but we don't have a largest value. Okay. Numbers bigger than 3 is going to keep going on and forever and ever. It's going to go to infinity. So our smallest value is 3. Our biggest value is infinity. 3 has an open circle, so 3 is not included. And infinity always gets a parenthesis. So both of these are open. Okay. So both have parentheses, 3 to infinity. Okay. All right. The next one's another compound inequality, but this one's a compound OR inequality. So remember, when we graph compound OR inequalities, there's two sections to them. There's one is shaded to the left and one is shaded to the right. Okay. So when we graph this one, we'll need -1 as one endpoint. We'll need +1 as the other. I'll put 0 in the middle. Okay. And then you graph each one separately, but on the same number line. So the first inequality, x is less than or equal to -1. That's going to be closed circle at -1, shaded to the left. The second inequality, x is greater than 1. That's going to be an open circle at 1, shaded to the right. Okay. All right, so we already knew that. We know how to graph these. How do we write this as an interval, though? Okay, there's two sections to it. How can we write two sections as one interval? Well, you can't. You have to write two separate intervals for this. So for each part of the graph, you're going to have to write two separate ones. Okay, each one gets a separate interval. The first interval, what's the smallest value? Well, the smallest value, it's going to the left. It keeps going to the left forever. So the smallest value on this interval is -infinity. And it's going all the way up to -1. -1 is included, so it gets a bracket. And infinity never is. Infinity gets a parenthesis. The second interval starts at 1, and it goes on to the right forever. So it's going to go up to infinity. Again, infinity always gets a parenthesis, and 1, since it's open circle, since it's just greater than, that also gets a parenthesis. Okay. So 2 separate intervals for 2 separate pieces. Now, we have to signify that these intervals are together. We have to signify that they're part of the same solution set. So what we use is in the middle, in between 2 intervals, or 3 intervals, or 4 intervals, or however many intervals you have, in between the inequalities, we write the word or. Okay. On a graph, there's just that gap, but it's on the same number line, so we know it's part of the same problem. For an interval, we don't use the or, we use a U. So it's a U without a tail. If you remember when we were talking about compound or inequalities, they had another name. They were called unions. That's what that U is. That U is a union in set notation. So if you have 2 intervals, but they're part of the same problem, they're part of the same solution set, separate them with a U, a union. Okay. And again, that also means or. All right, these next ones are given the interval. We're going to write them as an inequality, and we're also going to graph them. So the first one, we got parenthesis -5, comma 7, 7 as a bracket. Okay, so we have 2 endpoints here. If there's 2 endpoints and they're both numbers, you're going to have a compact inequality. That means we're going to have x in the middle. Okay. Our 2 endpoints are going to be -5 and 7. Okay. So it's going to go on the ends, and then we need the signs. This interval is stating that our solution sets are all values between -5 and 7. -5 has a parenthesis, so it's not included. So it's going to have just the less than sign. 7, so the interval goes up to 7. 7 has a square bracket. So that means 7 is included in the solution set. So 7 is going to have the less than or equal to. Okay. So you can see that interval, the intervals are easier to write. They're quicker. They tell you all the information you need just in the shorthand method. All right, on a graph, okay, same thing. They all have different parts, but they all represent the same thing. So we're going to have the -5. We're going to have the 7. Again, this is not to scale. 7 is going to get a closed bracket or a closed circle because it had a bracket and it has the or equal to. -5 is going to get the open circle because it doesn't have a bracket as a parenthesis and it doesn't have the or equal to. And then you would shade between them. Okay. The second one, 10 to infinity. Okay. So we got parentheses around both. So what that means for us is it's going to be, we're looking at all numbers that are bigger than 10 going up to infinity. All numbers that are bigger than 10, 10 is the smallest value. So our inequality is going to have x, and it's going to have 10, and we're looking for numbers that are bigger than 10 or greater than 10. Okay. 10 doesn't have a bracket, it has a parenthesis, so it's not going to get an or equal to. So just x is greater than 10. On the graph, there's only one number, so you only need one. We only need the 10 in the middle. And we're shading to the right. We're shading towards the bigger numbers, which goes to the right. Now at 10, we're going to have an open circle. Because 10, again, it has the parenthesis. It doesn't have the or equal to in the inequality. So it gets an open circle shaded to the right. Just a couple more now. This one's it's getting a little ridiculous now. But you could have more than 2 intervals. You could have 3 intervals. You could have 4 intervals. You could have as many intervals as you need to represent the solution set to a problem. So this one has 3 intervals, which means it's going to have 3 parts to the graph. Okay. So on this graph, we're going to need all the numbers that are included as endpoints. You don't graph negative infinity. We will graph 5 and 7 and 10 and 12. I'm going to spread these out a little bit. Okay, so those are my endpoints. I spread them out just because it's such a long line. All right, and go piece by piece, one interval at a time. The first interval is from negative infinity up to 5. 5 has a bracket, so 5 is included. So we're going to graph that first one. We're going to shade from negative infinity, which is this left arrow, up until 5. 5 has the bracket, so 5 is included. 5 gets a closed circle. So that's that first one. All right, there's that union symbol. Again, that just means or. So you could have your answers are in that first interval from negative 5 to infinity. Or it could be in the second interval from 7 to 10. 7 included, 10 is not included. 7 has the bracket, 10 does not have the bracket. So 7 is going to get a closed circle. 10 is going to get an open circle. And the interval says it's all values between those two. So your answer could be in that interval. Or, that union again, or it could go from 12 to infinity. Okay? 12 has a bracket, so it's going to get a closed circle. And then infinity goes to the right. So you have 3 separate intervals, 3 separate parts of the graph. Also means you're going to have 3 separate inequalities. You could use the interval to make the inequality. You could use the graph to make the inequality. It doesn't matter. But this first one are values that are less than 5. So your solution, your x values, are going to be values that are less than 5. Okay. Because it's shaded to the left. Now, if 5 has a closed circle, so it's not less than, it's going to be less than or equal to. Okay. For an inequality, we don't use the union symbol. We just write or. So or the second interval, from positive 7 to 10, x is between 7 and 10. 7 is included, so less than or equal to x. 10 is not included, so less than 10. Or the last interval, 12 to infinity, numbers that are bigger than 12. 12 is included, so we're looking for numbers that are bigger than or greater than or equal to 12. So 3 forms. You got your interval form, you got your graphing form, and you have your inequality form. Okay, we're going to be able to go in between each of those. All right, and then these last two, these are kind of special cases. This is where, interval notation isn't the best notation to use. If you have the inequality, x does not equal 10. We talked about how to graph that earlier. If you have x that does not equal 10, that means you're going to have an open circle at 10. But your solution could be anything besides 10. So that means both directions would be shaded. So every number that's not 10 is shaded. Okay. How would you write that as an interval, though? Okay. Well, you have 2 separate parts. That open circle is kind of the stopping point. So you have the open circle to the left, you have the open circle, and then moving to the right. So you need 2 separate intervals for this. The first interval, again, you start at the furthest to the left. You start, at the smallest value. Well, there is no smallest endpoint here, so it's going to be negative infinity. So we're going to start at negative infinity. Negative infinity always gets a parenthesis. And where does that first interval stop? It stops at 10. So it goes up to 10, and 10 is not included because it has that open circle. Okay. So that's the first interval. The second interval, well, where does it start up again? It starts again at 10. And how far does it go? Well, it goes to the right forever. It goes to infinity. So this is where, writing the interval is longer. Negative infinity to 10, 10 is not included, and then 10 to infinity, again, 10 is not included. And the last one is x equals 10. Because normally we don't graph equalities, but you can, and we talked about that before. We represent it with just a closed dot at 10. How would you write that as an interval? And again, you normally wouldn't. No one writes a single answer as an interval, but you can. Okay, it starts at 10, it ends at 10. Those are your only 2 options. It's not really an interval, it's just a point. 10 is included, so both get brackets. So from 10 to 10, 10 included, that's your interval. So again, those are special cases. Those are scenarios where we wouldn't really use an interval to represent that solution set, but you can. All right, so that's interval notation. Again, you guys should be comfortable in the future going between each of those three forms.